Hello and welcome back to CEMA's podcast. Y'all ready for this? Where we talk about all things emergency preparedness to make sure that you and your family are ready for any type of natural or man-made disaster right here in Chatham County. You guys, this week we are in for a treat. We are joined by Warning Coordinator Meteorologist Ron Morales. Ron, I don't know how you say that on a consistent basis. Thank you for joining us here today.
Oh, you're welcome. Thanks for having me.
And as always, we have Sakile Johnson. I don't know what I'm going to do, Sakile, when your Vista term ends. You have been my podcast partner for almost a year, and I don't know what I'm going to do, but welcome back.
Thank you for having me again.
Absolutely, of course. All right, guys, this month, February, is Severe Weather Preparedness Month. So we are talking with Ron about how to prepare for unexpected weather. Now, a lot of times, for those that have been around in the podcast world with us for a little bit, you know, we talk a lot about hurricanes and we talk a lot about how you can prepare for those. Hurricanes are things that you can typically see coming for a while. Sometimes it's like a turtle that's just stalking you forever and you're like, is this storm ever going to come? Today, we're not talking about that. We're talking about fast weather, unexpected weather, things like tornadoes, severe thunderstorms, things that we don't necessarily see coming immediately. But Ron might see them coming before anybody else because of what he does and his experience. So we're going to kind of work through that process and talk about a little bit about the science and what you all need to know as consumers from what Ron pushes out through our weather. So let's start with unexpected weather. It's on everybody's minds. How do we receive alerts first and foremost, Ron? What's the most important thing for people to do or sign up for?
Yeah, thanks, Chelsea. So we call that kind of stuff short fused warnings, which means there's not a lot of time between when we detect it and when some sort of an alert or warning goes out. And nowadays, there's so much technology that's available that we've really kind of, arguably anyway, removed the part of the equation where we would say, did people get the warning? Years ago, that wasn't a legitimate question because we had things like NOAA weather radio, which is one way to get our alerts. If you have one of those radios that is specifically designed to pick up our products, actually it picks up more than the warnings. It can have forecasts and observational data on there, like what the current temperature is and weather. So the weather radio is a tried and true way to get our weather information, like a tornado warning, for example, or a severe thunderstorm warning. The thing about weather radio, though, is it can only alert down to the size of your county. So if you're in Chatham County, you can set up your weather radio to alert everything that's coming into Chatham County. Well, that might be still an over alert, if you will, if you say live in Tybee Island. So, you know, it's pretty far away and maybe the weather is going to stay, you know, mainly along in, say, west or north of I-95. So it's kind of the northern part of the county, north and west. So that's not the greatest with today's technology. A really good one right now is something called the wireless emergency alert, which comes resident on all cell phones now. That ability to receive certain warnings comes on your cell phone. So the ones that you get right now are tornado warnings, flash flood warnings, and we're going to deal with the short fuse stuff because there's also things like hurricane and storm surge, but those are longer fused, as you had alluded to earlier, where you probably had at least days in advance to get that information, prepare, and do whatever it is you're going to do. So we've got the tornado warning, flash flood warning, and now we have the ability to alert some higher level severe thunderstorm warnings. The severe thunderstorm warning is kind of the more generic warning that deals with winds of roughly 60 miles per hour or greater and or hail of 1 inch in diameter or larger. Right now, or previously, none of those would ever go across wireless emergency alert, mainly because we issue a lot more of those than we do tornado warnings and even flash flood warnings. So we didn't want to over alert people, but in my world, the warning coordination meteorologist world, we thought that it would be appropriate to alert people when winds were, say, I think the threshold is something like 80 miles per hour or higher, hail of, I think, 2 inches or more. And I'd have to go back and double check on what those values are, but something more significant where there's very much a high likelihood of some sort of damage and possibly injury with that. So that'll come across your phone. Why is that important? Because your phone is GPS based, and we put out warnings that go in an area, or what we call a polygon. So we rope out, if you will, an area of concern. And even that's going to be an over warning. Not everybody, in fact, most people in that little box, even though it's much smaller than the size of Chatham County, are still probably not going to experience, say, large hail, strong winds, or a tornado or flash flood. But it's definitely more focused. And you don't even need to know where you are. Your phone will say, I detect that this polygon is where we are, where you and your phone are located, and it sends an alert out to you that this alert is valid for your region. Of course, there's TV and radio and partners like yourselves that are also taking our information and sending it out to your partners, and in sometimes the general public. We send stuff out through social media. So there's lots of different avenues to get this. And that might actually be an overload to some folks, because you might have multiple ways just in your own house, which is good, but you've got to sort of be able to filter the noise and say when it's something that you're concerned with, and when it's something that maybe, okay, that's far away from me, or far enough away from me, it's moving away, I'm not too worried about it. So that takes a little different level of education or awareness.
Yeah, absolutely. And something that's kind of cool too, CEMA, we are not meteorologists. We do not have that type of expertise or skill set, but everything in our standard operating procedures is to literally flip to or go to National Weather Service Charleston, find the graphics that they're already pushing out, and redistribute those. So everything that we're doing is based off of what Ron and his team put together. So it's an amazing partnership to have, for sure.
Yeah, thank you. And partnership is key. I mean, we can't do it alone, and that's why media, emergency management, we're all part of a team to get a coordinated, consolidated message out to the world. We don't reach that many on our own, but all together we reach a lot more. So you have to have those partnerships in place, or really the whole system kind of doesn't perform at the level that it should, let's say. I'm not going to say it fails, but it certainly doesn't perform at the level that it should.
That is very true. So we talked about NOAA weather radio. Chelsea kind of hinted at CEMA alerts and other infographics that CEMA disperses. What are some other things you recommend people do to get prepared for unexpected severe weather?
Well, the most basic thing I always tell people to do first, and this is going to probably sound funny, but is to understand what hazards impact your area. And by that, I mean, maybe you just moved here from Ohio or New York or whatever, and you're not used to tropical systems, hurricanes, or you're not used to the type of rainfall that we can get in 1 hour, or the type of severe weather as far as maybe the frequency of it or the timing of it. In other words, maybe it happens at a different time of year here than it did where it used to or where you came from. So understanding what types of weather, what type of hazardous weather impacts your area and when, so that you can that's why we do things like severe weather preparedness or awareness weeks, like is going on right now for Georgia, where it just sort of highlights to people that, hey, this is the type of weather that happens. Here's some ways you can prepare for it. So first, knowing what happens in your area, then knowing where to get the information, like we talked about before, with your local emergency management, of course, your local media outlets and TV forecasters. Know where your local National Weather Service is. We're located in Charleston, but we serve your area down there in Savannah, actually all the way down to the Altamaha River. So understanding where your services are coming from. Check out our webpage, check out CEMA's webpage, go to your local media web pages and see what types of information are available. We talked about getting things like weather radio alerts and wireless emergency alerts on your phone. There are many, many, many apps out there that I don't know. I know much less about than the audience does. I can guarantee you that. And there are many out there, like FEMA, for example, and Red Cross have free apps that provide weather information as well. And of course, wireless emergency alert on your phone is free, but there are some that you can pay a nominal fee for and get, great service from as well to get those alerts and prepare. But next is, what are you going to do? Do you understand what a tornado can do to you? And that might sound silly, but there are people that over the years, maybe, or through their lifetime, have said, you know what, I've heard these warnings before, and nothing ever happens at my house, and they dismiss it. And I get that. That's a big, big problem in our world and in our society. But you do need to understand what a tornado does to you or can do to you and your property. What do any strong winds from a severe thunderstorm versus a tornado? One is circular in fashion and the other one is straight, but they both damage. They're both strong. What are you going to do to be safe? And I don't know if we want to specifically talk about that next or at some point, but that's what we cover in our storm spotter training. I spend a lot of time talking about how to stay safe from these while observing them and letting us know, and emergency management and media know, what type of damage is going on, because that's the feedback that we need while we're issuing the warnings. So those, knowing what kind of weather is around, where to get your products and services like warnings, and understanding what you're going to do if you are potentially going to be impacted by, say, a flash flood or a tornado or some sort of wind or hail. What are you going to do? What's your plan? Do you have one?
Yeah, absolutely. Thank you, Ron. A couple of things that I thought of as you were talking. One, we're not going to get into it on this specific podcast. It's actually going to be our next one in Severe Weather Preparedness Month, talking about exactly what you should do during that severe weather. If there's a tornado warning, what you need to do, what you need to be looking for. And another thing Ron had mentioned, kind of let the cat out of the bag. Ron is hosting on our behalf a storm spotter class on February 23rd, and that's going to be in the evening. He will be able to answer questions, provide all kinds of in-depth information, and that would be a fantastic way for you to be able to engage and learn and see how you might be able to have some two-way communication with the National Weather Service about what it is that you are doing. Ron, maybe at the end we can try to recap a little bit about what that class is and how they can register for it and how it's delivered. But I'd like to get in a little bit into the science. Ron, I've had the opportunity to see your office and the incredible work that goes into all of your meteorologists, kind of the systems that they have set up and what they're monitoring and what they're looking at. Can you explain to our listeners a little bit about how the science comes into play when you say there's a tornado warning? What is it that you're seeing, and how do you get those messages out as quickly as you do?
Yeah, excellent question. Hard to describe it in words. And this is something that I actually go through in a few slides for the storm spotter training, where I set up a scenario to show how this works, because it may actually shock some people that there's a lot that goes into it. And each time, there's one storm that we're looking at, there may be more than one. There's probably several on the radar that we look at, but our primary instrument that we use to figure out whether something needs to have a warning is the radar. And it's a very powerful instrument. We have to go through a lot of training to understand how to use the Doppler radar. So it's a special, Doppler's been around for many, many decades. And the difference between just a regular radar and a Doppler radar is that the Doppler radar not only detects the severity of the storm by pinging energy off of a particle like ice or raindrop, and it bounces back and the radar listens and it says, oh, that's a lot of energy, that's a strong storm. That's not so much energy, that's not a strong storm or a weaker storm. But it also, the Doppler portion of it detects the motion relative to the radar. So if I'm the radar, I can detect whether things are moving away from me or toward me, okay? So there's a lot of interpretation that goes in there. There's a lot of implying of what this signature is. We don't necessarily, almost never see the actual tornado itself on the radar. It's too small, especially if it's more than 20, 30, 40 miles away from the radar. So we're never really seeing the actual funnel. We're seeing the parent circulation, which is higher up in the atmosphere, that maybe is on the scale of 2 to 3 or 4 miles wide. So that we can see. Okay, and then we're implying underneath of that what is going on. Now, the trick is to make sure that you're getting that out before the weather occurs. Okay, that's a big trick, or that's a big if, right? Because if you get the tornado warning out after somebody says, hey, there's a tornado on the ground, we're too late. Okay, that doesn't mean all is lost, as I explained in the class, but statistically, by verification standards, it's a miss for us. And it is important for us as an agency. We do report to Congress, and the president is our boss. So if we do not perform adequately, that's a problem. And so our statistics are important, but they're not everything. And we understand that service isn't just by a statistic. It's also by communication like this, about partnerships that go on before storms and after storms, and teaching people through storm spotter training of what severe weather is and how it impacts them and how they can stay safe. That's not all packaged in a statistic that says how many warnings you've missed or how many you've got, verified. Because that's ultimately why we need the reports. We need to verify that the weather actually occurred. And you might say, well, don't you guys already know that? No, we see it on the radar. Now, the one time we can know it is if a tornado, for example, is actually it's strong enough to create debris. Okay, it's damaging things on the ground and it's throwing trees, cars, pieces of homes, or whatever up into the air. Our radar can see that. It's called a debris signature. It's an indication that there's a damaging and powerful tornado on the ground. But if you wait until that signature occurs, you're too late. So that's a verification that something is happening without eyeballs. We can use that. It's called a radar indicated tornado, that we don't actually need a human being to report back to us, but we want to get it out before that. So all of this is going on in a split second. There might be more than one radar operator for big events. So we're talking to each other. We're coordinating that. We're getting those out. We're following up with messages that are saying, hey, the tornado is now here, or the storm is now here, or hey, this is now producing 2-inch hail, and maybe it wasn't producing any hail before, or there's damage that we're reporting, and we're following up with that. And then we're deciding whether another warning needs to be issued. Is the storm continuing to be strong, or are there new storms that are popping up? All this is going on while we're watching social media, NWS chat, local TV, coordinating with other offices, coordinating with the Storm Prediction Center in Oklahoma. All of this is simultaneously going on with just a handful of people in the office. So it's a very intense, very stressful situation, equivalent to air traffic control, coordinating planes, flying people through the air. So I can't adequately really describe it to you. You would have to see it in action to really understand it.
Wow, that's incredible. I've heard you explain this several times. I've never seen it because I'm always in our own version of a bunker trying to do similar things, but our message can't come out. Emergency managers' messages are irrelevant if there's no science behind it. So until National Weather Service can say, hey, this is what you need to be aware of, there's nothing that CEMA can do. We have to just be a pusher of the messages that already exist from National Weather Service. So that is incredible to hear, Ron. That's a lot. And I'm sure it is incredibly stressful trying to figure out, do we push this out? Are we right? What if we're not right? What kind of implications does that have? Because it's not just you all sitting in the office, but when you push out an alert, that sends ripples throughout communities. So that's a crazy job.
Yeah, sorry, I didn't mean, getting back to your partnership, that's invaluable. Okay, so we appreciate what you do and that you're trying to push that information out. And the other thing I didn't mention was kind of the emotional side, the psychological side of this. Okay, it's it could be very, very stressful to a human being to go through this, particularly when we know that there has been major damage and or deaths. When we had to deal with this in 2020, last April of 20, it seemed like last year, right? April of 2020, we had 6 people die. And that's the first time that I remember at least in a long time, going on site to a place where people have died. And it's very sobering. It's sad. It's frustrating because we spend so much time. Our mission is protection of life and property, and you can never totally get that done. And it's super frustrating. And I can assure you that we have the most dedicated staff, dedicated scientists and people and human beings at our office that are looking out 24 hours a day for everybody in our area to make sure that you are as safe as possible. It's a lot of weight on an individual's shoulders, but it's something that we're dedicated to do every single day.
Yeah, that is a huge and awesome responsibility. I know we're grateful for your work over here at CEMA, and I'm sure everybody listening is as well, or at least I hope they are. We kind of got into the forecast process a little bit when you talked about the Doppler radar. Is there anything else you want to mention about understanding the process and the science behind the daily forecast, the thing that so many people start their days with?
Gosh, this is truly very, very difficult to describe verbally, because you would have to really see the operations to understand. But I'll try to break it down as simple as possible. Let's just think of the regular forecast: today, tonight, tomorrow, out to 7 days. Even on a day where it's sunny out and people think, what's a meteorologist doing? There's nothing going on. Well, routinely, we are producing these products, actually updating them every 3 hours or more. That was a change that occurred more than 10 years ago, called enhanced short-term forecasting, where we are mandated in our region anyway of the National Weather Service, which runs basically from Maine down to us. That's the eastern region, to update these a lot. And of course, anytime the weather is not, or our forecast is not adequately describing the weather, then we're updating that as well. So it's a constant. So that's going on aside from the warnings, okay? That's in addition to, and this is never ending 24/7. Whereas warnings, there's ebbs and flows to them, right? I mean, the severe weather isn't always occurring, but the forecast always occurs. So we do it graphically. When I first started 30 years ago next month, I started in the Weather Service, and everything was typed. Everything was typed out for all the different areas of your forecast area. So in our case, we have 20 counties. You would type out 20 different county forecasts or zones and do that by hand for 7 days. Actually, it was 5 days, and then we punched it out to 7. And then around the year 1999, 2020, we came up with what was called the Graphical Forecast Editor, or GFE. In short, what this is the ability to pull in model data, to pull in human data and manipulation of temperature, wind, precipitation amounts, probability of precipitation, and dozens of others, all the way out to 8 days. And what it is those, if you picture, like, let's think of the high temperature for today, we would have an image for that, and it would have the high temperature forecast across our area. Similarly for low temperature, and then we'd have hourly temperatures. Those would then get ingested by a computer formatter, if you will, a program, to say, oh, okay, that turns into today mostly cloudy with a chance of showers, high in the 40s, wind northeast 10 to 15 miles an hour, something like that. Okay, so we're manipulating imagery, graphics that are made up of model data, blends of models, of many models, and of human interface as well. All of that goes into the forecast for 8 days. So it's like I said, it's really hard for me to describe here verbally. It's also an intense operation, one that never stays the same. Our models are constantly changing. The way we ingest the data changes. How we pull, what types of models. Blending is the big thing. So in other words, one model no longer is used, very rarely. Now it's a blend. So think of a bunch of models, and you pull them together and you average them, but you average them in a scientifically smart way, like weighting them to what one seems to do better than another at times. So it's super complex. Actually, it's getting to the point beyond comprehension of a lot of forecasters now, because it's getting that complex. We're trying to maintain the fact that we're meteorologists and that we're not just pushing buttons. So where is our part now? Warnings, and interpreting and doing decision support. So instead of me worrying about every little detail of the 8-day forecast, I'm going to talk to you as the emergency manager and say, hey, this is what we think is, if you're asking me, this is what we think is going to happen today and when it's going to happen and what it's going to do. And then you take that information and you say, thank you very much. Here's what I'm going to do with it on my end. So that's called decision support. And that can be as simple as you calling up for a forecast tomorrow saying, I've got a picnic outside. What's the weather going to be? To us briefing the governor or mayor or emergency manager director about where the hurricane is going to go, and they're worried about evacuation. So there's all different levels of this, and I could spend all day on that part, but I hope I didn't confuse you. But it is a lot that goes on, and it's very hard to describe verbally.
No, I think that was amazing to hear. And there's so many different working pieces. We often don't, at CEMA, at least in emergency management, we don't hear about the side you just described, except for the decision-making part. We're very familiar with the decision-making part, but how just a regular forecast is put together and the nuance to that and the intricacies that are all involved, like that, it's pretty incredible to think about. Most of the time when we call you, we need something very specific. No, how's the weather going to react to this? Or how can we respond to this? And there's so many different pieces that go into you all answering that question that for the most part, we don't think about because that's not our focus. So this has been really fun for me to listen and to understand.
Yeah, and that's super challenging because each partner has a different requirement, and some are have very specific needs. Downtown Charleston, for example, needs to know exactly how much the rain is going to be and when it's going to be. And of course, that stretches the limits of our science. And remember, we're constantly putting that forecast together and ingesting new data. It's almost continuous. The data is updated almost continuously, which means we have to constantly keep looking at it going, is that in line? Is that matching? And remember, we've had some winter events too, which we don't get much of. And really, I have to say our office has done an outstanding job with dealing with weather that generally doesn't occur here, but once every 2 to 3 or 5 years, and really nailing it. I know that the general public might not see it that way, but I can tell you meteorologically that there really isn't much better. We really can't improve much on the forecast. It's more about how do you get the information out and get people to understand it and believe it. Stay off the roads, that kind of thing. Stay off the bridges, understanding what's going to happen.
I can repeat that a million times over, Ron, 100%. You guys nailed it completely for the winter weather incident that we had just in mid-January here. But to get people to listen that there's a possibility of their pipes freezing and things that they need to do, that doesn't happen here. We don't need to do that. And then we hear people's pipes freezing and they're like, oh, yeah, maybe it can. So that is by far the biggest challenge. I appreciate that. All right. So I think the last piece that I wanted to touch on, Ron, is what we've kind of mentioned a few times, and that storm spotter class that's coming up. Anything else that you want to add about what people might learn in that storm spotter class, or really the benefit of taking that?
Yeah, the first thing I want to say is it is virtual. So I think probably a lot of people in the world are used to virtual meetings nowadays.
Yeah.
And the struggles and the challenges that go along with that. It is not the ideal way to teach this class, but I think it'll work. So be patient with me and anyone else that has to do it. Inevitably I have some sort of technical issue. I had one last week that was just ridiculous, and I use this stuff all the time, and it never fails that something's going to happen. But so there's no prior knowledge needed for this class. You can come in completely cold, and hopefully my goal is that everyone walks away learning something. I know I always learn something from the audience usually, and walks away saying, okay, I understand now more about the weather that's around me and how to stay safe from it. Even if they never report the information to us, which is the kind of end result of this training. If they never report to us again and never talk to us again, that's fine. I always tell them that I hope you learn something that then you can pass along to a friend, a family member, or whatever, and so on. That force multiplication of taking information from one point and then passing it down the line. That's that's how it works, because I can only train so many people a year. You can only train so many people. So the class runs about 2 hours, and the more questions, the better. I can never really seem to get it much less than 2 or 2:15, 2 hours and 15 minutes, but there's a lot to cover. But I always tell people too, that if we don't get through all the slides and I'm just answering questions, it's never really happened, but I'm prepared to do that, that the slides in themselves are not important. It's the information and me trying to interact with the audience that's important. And of course, that has challenges when you're doing it virtually, because you can't see people's faces and their hands raising necessarily and all that. So that's what they can expect. And when they walk away, they'll have a better idea of who we are, what we do, how to serve, how we all serve each other as a team. That's really the gist of it.
Awesome. Yeah, and I think it's important to reiterate that we are a team. It's not just emergency management and the National Weather Service. Residents play a huge role. And that's one of the reasons of the Storm Spotter class, is so that we can have that two-way communication. National Weather Service really benefits from on the ground truth, and our residents are ones that can provide that for them. So if you're interested, you can head over to the CEMA website, chathamemergency.org. We'll get you all registered and signed up and get you all the information that you need to be able to hang out with Ron for 2 hours and hear all of the stories. I've taken this class from Ron, I think 3 times now, and every time I learn something completely different. So I definitely recommend anybody sign up and take it and learn something pretty valuable and pretty important. All right, any final words, Sakile?
No final words for me. Just looking forward to that Storm Spotter training.
Yeah, Ron, any final words from you?
Now, first, thank you for inviting me on the show. And second, thank you to CEMA for all the years. I've been here now, this will be my 14th year. And all the years that you guys have hosted so many Storm Spotter trainings. It's been hundreds of people that we've trained between you guys hosting those over the years, hundreds, and maybe more than 1,000 actually, if I went back and counted them all up, because back in the day, we used to get a lot of people and we had many, many classes crammed in at once. Thank you for all the support through the years, all the partnership. We can't, do it without you. And it's so very important to have that team. So I want to thank you guys for that.
Absolutely. So Ron mentioned he's been with the National Weather Service for almost 30 years, and almost half of his career has been right here in Charleston, right here with us. So we appreciate that. Ron, thank you for your service. I know you're not going anywhere anytime soon. We're not ready for it. So we'll keep going with this, and we'll get you maybe over halfway with your career with National Weather Service before we'll let you leave us.
Yeah, it's funny. I never thought of it that way. You're right. It's almost half of my career here.
Yeah, so we'll get you over halfway, and then maybe we'll consider letting you retire at that point, right?
Oh, thanks. Appreciate it.
All right. Well, listeners, thank you for joining us today, Ron. It's always a pleasure having you on I almost said our show. It's a podcast. We'll call it a show. We appreciate having you. I'm sure we'll drag you into something else soon. We got hurricane season coming up, but right now we're going to focus on severe weather season with that coming up here. But listeners, until next time, as we talk more severe weather preparedness, stay safe, make good choices, have fun. Bye, guys.
Thank you.